SJE-Rhombus, and we're out of Detroit Lakes, Minnesota. I've only worked for them for 3 years, but hopefully you won't hold that against me. And if you're not familiar with SJE-Rhombus, Detroit Lakes, Minnesota. Back when the company was formed in 1980, a gentleman by the name of Steve Johnston started in a steel building out behind his house. And in Detroit Lakes, Minnesota, we've got over 500 lakes within a 25-mile radius. And so it's a bit of a vacation destination for a lot of people in Minnesota and North Dakota. Steve had a lake home back in 1980 that had a holding tank for his septic. Most of the lakes around there, like a lot of areas, they don't allow conventional septic systems, so most of the lake homes used holding tanks. And Steve got tired of sticking a stick down in the riser of the tank to know when it's full. Seems like most of the time the holding tank would load up and be ready to be pumped just about the time you had visitors for the weekend or holidays rolled around. So Steve came out with a high-level alarm and a Mercury float switch to alert him when the tank was 2/3 of the way full. Since 1980, the company has grown, and we've got about 180 employees in Detroit Lakes, Minnesota. We are by far the largest employer in that area. And in addition to high-level alarms, we also manufacture control panels, float switches, for turning a pump on and off. We manufacture about 85% of the float switches used in North America. So I would consider us one of the leaders in that industry. Now, we sell a lot of float switches to the pump manufacturers as well as through wholesale distribution. So there's the company today. Detroit Lakes, Minnesota. You go to Fargo, North Dakota, and drive east about 1 hour, and you run into Detroit Lakes, Minnesota. One of the things I would encourage you guys to do if you ever travel much and you're going to be up in our area, give us a call ahead of time. Let us know you're going to be in the area. We love giving factory tours. We love visitors. We also, several times a year, have training at the factory. So if you guys can commit to a couple of days, we'd love to have you up. And we'll talk about control panels, get a little more hands-on than what we're going to do today. And we would love to have you up there. Typically, you get there, we take care of everything else. So far as meals and lodging while you're there, we'll take care of all of that. So if you're interested, come by my booth sometime in the next day and a half. You can take one of our business cards, and we'll let you know when we're going to have another training event. All right, Detroit Lakes, Minnesota. Like I said, we got a lot of lakes in the area. We have about 9 months of winter time, it seems like, in that part of Minnesota. Ice fishing, it's a big deal. So this time of year, as you can imagine, you get a small city on the ice. A lot of times we fish for things besides walleye, crappie, northern, musky, things like that. Every now and then you got to send a diver down, retrieve things like snowmobiles, SUVs, you name it, four-wheelers. The one thing I found about ice fishermen is there's no such thing as ice that's not thick enough. Generally, early December, you can have about 1 inch of ice on the lakes, and a lot of guys will be out there trying to put their fish houses out. So occasionally we do have to send a diver down into the water. Not all of our meeting today is going to be talking about Detroit Lakes, Minnesota. We're going to talk a little bit about the products that we manufacture. I tried to structure it in a fairly generic format so that some of the things that we'll go through today you can apply, whether it's a switch that we manufacture, a control panel we manufacture, or maybe our competitors. As we go, if you have questions on anything we're talking about, just shout it out. We don't have to be real formal here. Or raise your hand if you want me to call on you. We're going to talk about pump switches. We're going to talk about control switches. We'll talk about the difference between a Mercury switch and a mechanical switch. We'll spend a little bit of time talking about high-level alarms and then control panels as well. Difference between a pump switch and a control switch, there are some inherent differences. And when I say a pump switch, I'm talking about a switch we're going to run full load, full current through the switch to operate a pump. With a control switch, typically that's going to be used in conjunction with a control panel or a high-level alarm where you're going to have a relay. So all we're going to do with a control switch, when it goes up, we'll complete a circuit, energize a relay, and activate an alarm or a motor contactor on the panel. Wide angle switches are going to be used exclusively with pump switches. On a control switch, it's going to be a narrow angle of activation. Pump switch, as we already alluded to, the pump switch is designed to handle full load, full current to operate that pump. With a control switch, it's going to be limited to very low amperage, low current going through the switch. In addition to the full load amps to run the pump, it's also built and designed so that we're going to be able to handle the startup amperage of the pumps. Typically, that's going to spike when the pump first turns on. And the pump switches that we build are all designed to handle that inrush when you first turn the pump on. Both the pump switch and the control switches are available in a pump up or pump down configuration. On the control switch, typically we're going to call it normally open or normally closed. But both switches are going to be the same in the characteristic that it's either normally open or normally closed, depending on what we want the switch to do. Typically with a pump switch, we're going to have a piggyback option. So, and I've got a picture here in just a moment where you're actually going to take the power cord from the pump, plug it right into the switch itself, and then plug that into your power supply. With a control switch, it is always going to be hardwired, whether it's to an alarm or to a control panel. And there's a picture of a piggyback plug where we've got the switch that plugs into our power supply first, and then our pump cord that plugs into the piggyback plug or the switch. Whenever that switch goes to the up position, typically it'll complete the circuit and energize the pump, turn the pump on, switch drops down, shut the pump off. On the pump switches, in addition to having a piggyback option, more often than not on effluent pumps or sewage pumps, a lot of times we're going to see the connection hardwired in a junction box. We want to make sure if we are hardwiring the connection for an outdoor installation that we use a weather-tight junction box, like what you see there. And on the lines that go out to the sewage tank or out to the pump tank, we want to make sure we have some sort of sealant to keep sewer gas from getting into our junction box. One other thing I'd like to encourage is when we strip the wires back, it is possible in the J-box to get some condensation as you get changes in the temperature surrounding the J-box. That condensation has a tendency to actually wick down the cable insulation and can get all the way back to the float switch. So one of the things I would encourage you to do inside the J-box is also seal off that connection right there. I've heard some electricians call it, forgive me for my crudeness, monkey. Has a sealant, it's re-enterable potting compound, works very well. You can also use silicone sealant to seal off around that cable. What we're trying to prevent, we don't want any of the water, any of the condensation that forms in the J-box to make its way back to the float. All right, on a pump switch, we're going to control the length of operation for the pump by the length of tether that we come out from our discharge pipe or from our float tree. As you can see on the chart, the longer the tether, the greater the pumping operation range from off to on. All right, and you hit a certain limitation, you get enough cable out there and there's going to be no benefit to going additional cable. Typically that's going to be about 20 inches so far as the tether goes. You can run out another 20 inches beyond that and you're not going to get any additional pumping range. Some of the examples of some mechanical switches that we offer, I would consider this what I would call a conventional switch, just single float up and down for the off and on position. If we're dealing with a confined space, we've also got a vertical style float switch where the float itself is going to move up and down on a rod. The one negative to this style switch, you're going to be fairly limited on your operating range for operating the pump. We're going to be limited to about 6.5, 7 inches of your operating range with that style switch. But if you're in a confined space or a crowded pump tank where you just don't have a whole lot of room, a vertical switch may be a more reliable option for you so far as running your effluent pump or your sewage pump. And then we also build, and other manufacturers build as well, a double float with a holding relay in it. The double floats typically are going to require that both floats be in the up position for the pump to come on. Both floats have to drop down and be in the off or down position for the pump to shut off. So you can have a much greater pumping range with a double float than you would get with a single float or a vertical float. Typically, we're going to go up to about 6 foot on the pumping range for the double floats. Mercury switches are really what the industry was formed with, 30, 40 years ago, 50 years ago. A lot of states have gotten away from mercury. Mercury seems to be a dirty word, but I will say, as long as mercury is legal to put into a float switch, we'll offer them. The one thing we won't do is if there's a state that has outlawed mercury, we will not ship a mercury float into a non-mercury state. So keep that in mind. Iowa allows mercury switches, so that's still a viable option in this area. All right, here's just a couple of the different floats that we make on the mercury style pump switches. We offer a single traditional single float option as well as a double float. All right, most people have not seen the inside of a switch without cutting it open, so this slide gives you some idea what's going on inside a mechanical switch. This is one way of doing it where you've got a ball in a raceway. As the float moves up or down, that ball is going to move through the raceway and actuate a lever that engages or disengages the contacts inside the mechanical float. Mercury float, a little more simple in the operation. We're going to have a capsule with a very, very small amount of mercury in it. As the float tips up or down, it's going to either complete the circuit or break the circuit. Very, very reliable. With a mechanical switch, you do have mechanical contact points in there that can get carboned up. So one of the things I get asked very, very frequently is, what's more reliable, a mechanical switch or a mercury switch? Reality is, as long as mercury is legal, it's probably the route I would go. I will tell you, from a manufacturing standpoint, it is a whole lot tougher to make a reliable mechanical float than it is a reliable mercury float. Just because, again, with mechanical contacts, there are more problems that can occur on those contact points that you don't see typically with a mercury switch. So as long as they're legal, that would be the route I would steer you. For every mechanical switch, we have an equivalent of a mercury switch available too. All right, there are the states across the country that have outlawed mercury. There's 12 states in the U.S. It wouldn't shock me if in the next 10 years you see a whole lot more red on the map. Again, just because the negative connotation that goes along with mercury, most people just don't like the idea of releasing a harmful chemical into the environment. So I see that driving a lot of the legislation across the U.S. And my understanding is you have a hard time buying a mercury thermostat today, and I would think that float switches are going to go the same way as a thermostat. You're just seeing mercury less and less. All right, any questions up to this point? Fairly simple concepts. Yes?
Just on that, how do you guys get the mercury in your state outlaws?
Yeah, we're allowed to manufacture them there. We just can't sell them there. So, explain that. We're an international company. We ship all over the world. I'm told that as of January 1st, 2013, international law says no more mercury being shipped outside the U.S. So, we've not done a lot of that in the past, but that will put that to an end. But again, though we can't sell mercury switches in Minnesota, we can certainly manufacture them there.
When the mercury gets outlawed, was it a mechanical switch or is there something else?
No, we have other options besides a mechanical or a mercury switch, so far as turning pumps on and off. I will say from a cost standpoint, mercury and mechanical float switches, the reason they're as popular as they are is because they're very, very low cost, effective way of actuating, turning a pump on and off. So my guess is, for the states that are in red up there, we sell a ton of mechanical switches and no more mercury. I would say that if you're in a state that bans mercury, everybody just gravitates towards the mechanical switch.
Because Iowa adheres to the 10 state standards for wastewater regulations, and several of the states that use standards are being waived for disposal. Eventually, it's going to get out probably sooner than it will some of the other white states you see over there. It's coming.
Right, we're close enough to Minnesota, Wisconsin, Illinois. It's just a matter of time. All right, any other questions before we move beyond mercury? Yes, sir.
What's the load rating? Load rating?
Yeah, question is, what's the load rating on a Mercury switch versus a mechanical switch? For every Mercury switch that we manufacture, we have an equivalent of a mechanical switch. So on the mechanical side of the fence, we do 13 full load amp, 15 full load amp, and 20 full load amp, depending on the series of switch that we use. On the Mercury side, we're limited to 13 or 15 full load amps, which is good for probably up to a 3/4 horsepower pump, depending on who the pump manufacturer is. All right. Talking about control switches, as we already mentioned, we're not going to carry any load with a control switch. It's going to be used to actuate a relay for a high level or low level alarm, or a control panel where we're going to use a coil to energize or de-energize a motor contactor for turning pumps on and off. With a narrow angle switch, we're going to have a little bit different setup. With the control switch, we want to have at least 3.5 inches of tether, but we don't need any more than that. The longer the tether out from the pipe or from the float tree, the greater the chance it's going to hang up on something. All we need is 3.5 inches, so I would encourage you on a control switch with a high level alarm or a control panel, limit it to about 3.5, 4 inches of tether coming off that discharge pipe of the pump or the float tree. And then actuation on a control switch, most of the control switches that we manufacture are going to be narrow angles, so we're going to have 1.5 inches above or below horizontal for the activation point. There are some other float switches on the market, control switches, that are going to be a little less than that, maybe 1/2 inch above or below horizontal. And then just a couple of different control switch mechanical options that we have. Same thing on the control switches, we also offer a Mercury version. And I'm jumping right through those. All right, talking about level alarms a little bit. We're going to have really 2 different styles of level alarms, and whether it's a low level alarm or a high level alarm, we're going to offer them in an indoor version as well as an outdoor version. Some of the things I would recommend that you look for if you do sell your customers high level or low level alarms. On the indoor alarm, some of the things that I think should be standard features on your alarm, if it's a NEMA 1 rating, it's not rated to go outdoors, so it's going to have to be an indoor installation. The audible alarm with a silent switch is a good idea. The last thing the homeowner wants in the middle of the night when they wake up by a high level alarm is to go down there and not be able to quiet the doggone thing down. So a silent switch kind of goes without saying. Here you're going to have a silent switch that somebody's going to press to quiet the thing down. And then I would recommend that it has auto reset. And we actually still make an indoor high level alarm that if you silence it, you're going to move a switch over to the right position. And unless somebody remembers to move it back to the arm position, you'll no longer ever get an audible alert. So, excuse me, this particular series of alarms that we manufacture, it's going to be an auto reset. So if somebody presses that silent switch and the alarm condition goes away and the liquid level drops back down, it auto resets and is armed again. And I mean, that's one of those things that should go without saying. You want it to be auto reset, auto alarming. All right, it's also a good idea, battery backup. And again, one of the alarms we have on display in our booth today does not have a battery backup. For me, if I've got an alarm that's monitoring my finished basement, I want to have a battery backup. Chances are pretty good that the basement's going to flood in the middle of the night, in the middle of an electrical storm. And if there's a power outage in the house at that time that's keeping your sump pump from running, chances are pretty good that it's also going to kill power to your alarm. So by having a battery backup connection to your alarm, it just gives a greater chance that somebody's going to know that their basement's about to flood and they can move their valuables to higher ground. And then all the products that we manufacture, one of the things I would say that no matter who the manufacturer is, to have some sort of third-party validation that the product is safe and when used for its intended purposes is a good idea and a good safeguard for you and your customers. And then I would recommend you look for a product that's got a decent warranty that gives you some peace of mind that if you have problems down the road, it's going to be taken care of. Here's an example of one of our outdoor alarms. With an outdoor alarm, you're going to be looking for a NEMA 3 or greater rating on the enclosure. Just basically says that it's intended for outdoor installations. Blowing, precipitation is not going to negatively affect it. It's also intended for installations where you may get temperature extremes. And again, we're just going to pop through some of these. A lot of the same features that we look for in an indoor alarm, we'd also attribute to an outdoor alarm as well. One other option for a retrofit, we offer a wireless alarm. So if you've got somebody that has a pump tank where they want to monitor and know ahead of time if there's a high-level situation, you can add our wireless alarm to that, and beats the heck out of bringing a trencher out and tearing up somebody's yard. Anytime it's new construction, I would also always recommend that you go ahead and hardwire it. You're certainly going to get a little more reliable performance out of a wired alarm than you would a wireless, but it is a nice alternative on existing retrofit situations. All right, we're going to shift here to control panels and talk a little bit about the installation practices that are best designed for the control panel. One of the questions that comes up a lot, we know that we can control a sewage or an effluent pump with a lowly float switch that goes up, turns the pump on, drops down, turns the pump off. So one of the questions a lot of times is trying to convince your customer why they would benefit from having a control panel for their pump as opposed to just a switch. So one of the first advantages I'd like to point out is the fact you get a high-level alarm and a pump control in one package. Tends to look a little more professional to the homeowner, when they're spending, $5,000, $6,000, $7,000 on their waste treatment system. Looks like they're getting a little more for their money. Larger horsepower pumps, we know with the switches we're going to be limited to about 15 full load amps on what we can operate with a float switch. With a control panel, the sky's the limit. We're going to size the motor contactor to handle whatever full load amp rating we need for the pump. So we're not limited to a 15 full load amp upper limit for what we can operate. So larger horsepower pumps are going to be mandatory that we go to a control panel. Manual operation of the pump. I was talking to somebody earlier today and they talked about taking the lid off of the riser, sticking a broom handle down in there with a nail coming out of the bottom of it, lifting the float up to get the pump on or off. With a control panel, you're going to have an HOA, a hand-off auto switch on the control panel. It gives you the ability to manually operate the pump. So if you want to drop the level in your tank or you want to do service on the pump, it just gives you a lot more, it's a lot more user-friendly for your service call applications. Pump monitoring, we can add things like elapsed time meters or cycle counters to a control panel that lets you know exactly what kind of usage we've seen on our system. If we've got a three-phase pump that we're trying to operate, there's not a float switch made that'll operate a three-phase pump. So anytime we've got three-phase pumps, which generally is going to be a commercial application, it's going to require the use of a control panel. Duplex applications, and when I talk duplex, I'm talking two pumps where you alternate between the two pumps. We don't have the ability to do that and get even usage out of the pumps with just a pump switch. So with a control panel, we can have an alternating circuit inside the panel. It gives us even wear and tear on both pumps. External start and run components or cap kits for the pumps are going to require that we use a control panel if that's the type of pump you're using. And then intrinsically safe applications. And when I refer to intrinsically safe, a lot of times municipally or commercially, you're going to have an engineer that's going to require an intrinsically safe control panel. Basically, intrinsically safe is going to isolate anything that could potentially generate a spark that could ignite combustible gas. It's going to isolate it in a compartment of the panel away from where that combustible gas could be occurring. And so if it's an intrinsically safe requirement sized by the engineer, a control panel is the only way to go about getting that requirement met. And then with a control panel, we also have the ability to incorporate pump disconnects into the panel. So it just gives you a nice safe way of interrupting power to the pump. If you have to do any service work, you can incorporate either circuit breakers or rotary style disconnects into the panel. Allows us to kill power to the pumps. There's a few of the different applications where we see and manufacture control panels for. The vast majority of our business, probably 90% or better, is in the wastewater industry. Though we're seeing more and more on the clean water side of the fence with constant pressure systems. Some of the things we need to know to size a panel properly and get you what you guys need or get the homeowner what they need. Some of the questions we have, we need to know characteristics of the pump. We need to know the voltage of the pump, whether it's 120 volt or 230 volt. We need to know the full load amps of the pump so we can size the circuitry inside the panel appropriately to handle what kind of load the pumps are going to require. Control options. Some of your higher horsepower pumps are going to have options available on that, like a double seal pump. A lot of times will have a seal fail indicator that lets you know one of your seals have gone bad inside the pump before it causes catastrophic failure of the motor. We can incorporate seal fail circuitry into the control panel so you get either an audible and visual alarm or a light that comes on that says, hey, seal number 1's failed. Go ahead and get the pump rebuilt before you have, again, catastrophic failure. Thermal cutouts can be incorporated into the panel if they're not already on the pump motor. And then pump start kits, overload protection, all of that can be incorporated into the panel. We just have to know ahead of time that that's required. Some of the panel characteristics that we're going to incorporate into the panel, the enclosure style, and generally most residential applications you're going to use a thermoplastic or a fiberglass control panel enclosure. We get into some commercial jobs, they may require stainless steel, painted steel, aluminum, things like that. We need to know if it's going to be installed indoors or outdoors, so we get you the right NEMA rating on the enclosure. Number of pumps in so far as a standard product that we manufacture, if it's in our catalog, we do a maximum of 2 pump or duplex panels. But on the custom side of the street, we can build a control panel to operate as many pumps as you guys can dream up or the engineer can dream up. Intrinsically safe circuitry, again, we can build that into the panel. And then we can also incorporate things like elapsed time meters or cycle counters to give you some idea what kind of usage you've seen on the pump, circuit breakers for disconnects on the pumps, auxiliary contacts if you want to have notification of a high level event tied into a home security system. And we can incorporate auxiliary contacts into the control panel that ties into your home security system and allows the homeowner or whoever monitors the home security system to know you have a high-level situation even remotely. And then things like a lockable latch, another option we can incorporate into the control panel. Any questions on that at this point? All right, and then we've got the ability to do either demand dose or time dose with the control panel. We can do float activation for stop, start, and alarm points of the pumps, or we can do pressure transducers. Again, there are a lot of options there so far as what we can use to actuate the pumps at a certain liquid level. There's a basic standard panel that we manufacture. You've got, kind of hard to see on the picture, but there are circuit breakers incorporated into this particular control panel. There's the motor contactor there, and the terminal strip where you're going to wire your floats would be right there. Some of the different installation techniques you can use when installing a control panel with your pump, with your floats. Just a few examples, different methods for mounting the floats in the tank. We can go with a float bracket where you're going to hang the floats from the top of the tank. Typically this float bracket would be installed in the riser in the top, and then you would hang floats from each of those little positions there. If you're using a float bracket to hang the floats down into the tank, you're going to control the activation point by the length of cord that you have coming down into the tank, and your tether point is going to be controlled with a cable weight that's going to attach to the switch cable with our 3.5 inches minimum length of tether. And there's a picture of a cable weight. There's other style cable weights out there that are available, whether it's a 2 halves, like a clamshell lead weight design. There's a float bracket, so if you wanted to mount a float tray down into the tank, you could use something like that, or we can use cable clamp assemblies like what you see there. Those cable clamp assemblies can either attach to a float tree or the discharge pipe of the pump. Anytime you penetrate, whether it's a high level alarm, yes sir?
Question on that last one where you're talking about, you stated either to the float tree or the discharge pipe.
Yes.
As the manufacturer of those floats, do you have a recommendation to do that or not do that? Because I hear a lot of counties talking about not attaching to the discharge pipe, or certain contractors saying build a float tree or get a custom built float tree. I specifically install a lot of your guys' things for our manufacturer guys, so I guess I was interested in if you have a preference.
Yeah, question was, from a manufacturing standpoint, do we have a preference for how you secure the float switches into the tank, whether it's the discharge pipe of the pump or a float tree? You know, my personal preference would be a float tree that you can access from the top of the tank, so that if you ever have to do any service on the floats, pull the float tree up out of the top. Nobody has to get down in the tank. You don't have to pull the whole pump out. I think that's a cleaner way of installing it, a little easier to do service on it if you use a float tree like that. So that would probably be my preference from so far as warranty on the product and what effect
You guys
difference.
don't see any problem, like the thing I hear people talk about is, you know, your pump kicking on and off. That's the statement that people would say, that float kicking on and off would cause damage to that float or whatever. So I guess get it from the horse, I would say. That's why I was asking, you know. I see it we pump tanks, repair stuff, so I've seen it both ways, I guess. So that's why I was asking.
I think that there is benefit to cycling less frequently for the pump running for longer periods of time. So, you know, another advantage of having a control panel versus having just a pump switch would be much longer runs, less frequently, that you would get with a control panel where you've got correct, where you can have a stop point here, start point here, and you can, you know, separate them as much as you want. Now, I've got some slides coming up too that will kind of go through the installation, but so far as a manufacturing viewpoint, you know, I would probably point people towards some type of float tree just to make servicing on the floats a whole lot easier down the road.
We make an internally weighted control float switch that doesn't have to be mounted to anything.
Right.
It hangs on the top on its own cable. So if you have a control panel, that's another option. The easiest way I think the coolest way to do it is just mount floats to a chain, stainless steel chain, with a weight on
its own weight.
And then when you pull it out, you don't have this piece of pipe with all these floats mounted to it that you got to deal with, and yet you can pull it out, and then it's in there, not secured to anything. You can easily remove it. So either way, you know, on a mounted float switch.
All right. Anytime you penetrate the enclosure for a control panel or a high-level alarm, if it's an outdoor installation, we need to make sure that we use the proper type of fittings to seal the enclosure back up. When an outdoor enclosure leaves our factory, it's got a NEMA 3R or a NEMA 4X rating on it. It's designed with that rating to go into the environment and not have any problems. So if you penetrate to bring your cables, your wires into the box, you know, make sure you seal those back up so that you don't get either you know, rain or sleet or anything like that blowing up into the panel. So a couple examples, we've got what I would call liquid tight fittings that would work for individual cables. These are available for flat cables or round cables. We can also do conduit hubs so that you can bring in multiple cables through one penetration. If you use a conduit hub like that, I recommend that we seal that off if it's going back to a sewage environment. You know, if we've got conduit running from our control panel back to a pump tank or the septic tank, you've got sewer gas in there, and that conduit, not only does it bring your wires over to the panel, it's also going to bring sewer gas. So you need to make sure you seal that off either with silicone, monkey poop, or we make a cord seal like that that's re-enterable, allows you to run up to 3 cables. We got another version we're going to have out here in the spring that will allow you to do up to 6 cables through it. So those are some options for sealing that off. whether it's a high-level alarm or a control panel, if we have auxiliary contacts, we can also incorporate remote notification of a high-level problem or a high-level alarm with auto dialers. So I just wanted to mention to you that most panels, whether I made it or somebody else made it, as long as you have auxiliary alarm contacts in the panel or in the alarm, you can incorporate a dialer into the system as long as you bring a phone line into it and get remote notification if there's a catastrophic problem on any of your jobs. All right, when we do the installation of the floats, this is one setup here where you're going to see, if you could look up at the top of the tank, we would have a float bracket, and we have our floats hanging down. When I mentioned the cable weights with our 3.5 inches of tether, that's what I was talking about. Normal operation for the floats for a single pump application and a control panel typically is going to be 3 floats, where you're going to have a stop float, a start float, and an alarm float. And this graphic will just go through what actually happens in the tank. Liquid level comes up. When it hits the stop float and raises the stop float up, nothing's going to happen. Once the start float is reached, it's going to energize a coil inside the control panel, pull in contacts of the motor contactor, send power to the pump, and start your pump running. Normal operation, when that start flow drops out, nothing's going to happen. We've got a holding relay in the panel that's going to keep the pump running until we reach the stop point. And then at that point, we'll interrupt power to the pump, shut everything down. So we can control what the pump operating range is by separating the distance between our stop and our start flow, limited only by the depth of the tank. You know, the deeper the tank, the greater that operating range can be. And then we would recommend with your alarm float, you're going to have that high enough so you don't get nuisance alarms. You only get notified when you have a potentially catastrophic event. Typically, the high-level alarm going off is going to be a good indication that you've got either a pump that's bad or a float switch that's gone bad, something like that.
We can use this graphic to kind of address something along this earlier about the float switch. Go back. When we talk normally open or normally closed contacts in the float, or normally open or normally closed float, what's the normal position? Normal is hanging down. This floats in its normal position, or normally open. So, and 99% of the floats we sell are normally open, but you can get a normally closed switch. So contact would be closed when that float is hanging free with no liquid around.
Good way to remember it. Normally open is going to be for pump down. Normally closed would be for pump up. Typically wastewater situations where you've got a pump tank where we're going to pump it down, it's going to be a normally open switch. If we look at clean water where you may have a cistern that we're filling up, you want to fill it, we want to pump up, then you would use a normally closed switch for that application with the same control panel. All right. We're also going to talk a little bit about duplex control panels where you're going to have 2 pumps that we're going to alternate between the use. And we're going to talk about the float setup when it comes to a duplex 2-pump setup and how you use the floats and how you set them. We're still going to have a stop float. We're still going to have a start float. We're also going to have a lag/alarm float, like you see here. With a normal duplex system, when the start float is reached, 1 pump's going to turn on. We're going to operate until the stop float drops back out, and then it shuts off the pump. Next time around, pump number 2 is going to run. So you get even wear and tear out of both pumps. We're going to alternate back and forth between the 2. If we reach the lag point, you can see right there we've got 1 pump running. Once you reach the lag point, it's going to turn the second pump on, and they're going to run simultaneously until we hit the stop float again. So anyways, we also got the ability to separate the lag and the alarm function by going with a 4th float. So we'll talk about that. This is one of the areas where I find a lot of misunderstandings out there. When you have a 4th float that separates the lag function from the alarm function, what level should they all be mounted at? So this would be my preference, and we may have people out there that argue with me on this point. I'm pretty confident that my position's correct, and I'm happy to talk about it if anybody feels differently. But I'll tell you the theory behind why I feel it needs to be the way it is here. Normal operation, we're going to have the stop float go up. Nothing's going to happen. Start float goes up. Pump number 1's going to run. It's going to alternate to pump number 2. just like we did with the 3-float situation. If the alarm float's reached before the lag pump float, it's possible the alarm's going to go off for a little while. Pump number 1's going to go ahead and take care of the situation, pump the liquid level down until the pump shuts off. Once we reach the lag float, both pumps are going to come on and run simultaneously. Now, the reason I want my lag float at or above my alarm point is if we had a failure of pump number 1, each time, if we had my lag float down here and my alarm float up here, each time we hit the lag position, the pump that's still working is going to kick in and take care of the load. You may not know you've got a problem until pump number 2 fails also, okay? By having the alarm float at or below, at or below the lag pump position, you're always going to know if you have a failure of a pump before it's a catastrophic situation.
You would be able to tell that if you only had 3, right?
That's correct. If you only had
If
3
you use the
floats.
lag and alarm together, you won't signal that unless you see it.
Every other cycle, you're going to get an alarm.
Right. Say it's pump 1, pump
Yes.
4, whichever one.
That's right. That way the homeowner calls you up and says, hey, come check it out. I'm getting an alarm every couple of days. And you can get out there and see what the situation is. I've sat through meetings that pump manufacturers have given where they're going to tell you just the opposite on a 4-float setup. I've heard almost all of them say, we always want the lag float down here and the alarm float up here so we don't get nuisance alarms, so we don't get called up to go out onto a job when there's really not a problem. Reality is, if that alarm is going off, there's a problem that needs attention. So again, I would always recommend having the lag point as the highest float inside your tank and the alarm point at or below that. And we don't care if it's a 3-float or a 4-float setup on a duplex application. Both work very, very well. We actually like selling that 4th float. So if you want to go that route, we're big fans of that. But again, from a performance standpoint and life expectancy on the pump and how everything's going to operate, 3-float or 4-float setups or a duplex application, both are going to work quite well and are interchangeable.
You had a question?
Yeah. If, say in the instance you go out there, you install the system, you don't turn the system on right away because the homeowner isn't going to occupy it because of the time of transfer or something like that, then you don't get a notice that the homeowners are going to go out there and start using. So they come out there and they start running some water. Your stop switch comes up, but maybe the start switch doesn't come up, because they're maybe 3-4 days into it. They call you up and say, hey, I'm out here, I'm using some water. Is that control panel smart enough to know that that stop float's already up, or when you turn that on, is it going to think that because of the way the contacts are that it's down, and then it would be reversed, won't it?
It will not.
Or does that have to do with the always open or always closed?
Correct. The question was if there's been limited use in the house and they use enough water to where our pump tank now has the off float and the up position, when we go to start the system up, is the system smart enough to figure out that the stop float's already been engaged? It doesn't matter. It's not going to malfunction because it's still going to look for logical sequencing of the liquid level up. The stop float being in the up position is not going to do a thing.
It wouldn't matter if it was the stop float or the start.
Nope, it wouldn't.
No matter which sequence, if that thing was all the way full, you kick it on, it's going to see that and it's going to run.
Correct. The panel cannot be gotten out of sequence because you engaged one float when this one's still in a down position and this one's up. You can't get it. You can't pull the panel. You can't get it out of sequence. One other thing that we try to incorporate into the panel is that if the stop float is in the down position and you try to run the panel in the hand or manual position, you're going to have to hold it in that position to get the pumps to run. What we don't want is putting it in the hand position, no water in the tank, and you burn the pumps up. All right. Other questions, and if not, we're going to move on to a few installation picks that we've got here. And again, some best practices for doing installations. Some of the things seem very, very common sense, but if you guys, I'm sure if you've been in the industry for very long, common sense is not all that common a lot of times. And I never cease to be amazed at some of the installations that we come across. The first point we want to say is put the panel in an area that it's easily accessible, easy to do service work on it. And this picture here shows, you're going to mount the panel about 3-4 feet up off the ground in an area where you can actually get to it. I've actually seen panel installations where if you want to do service work on it, you got to lay on the ground because the panel is about 1 foot off the ground. So to do any wiring to it or do any service on it, you got to lay down. It just doesn't make any sense to me. I certainly understand why it sometimes gets done that way. People try to minimize the impact of a panel being out in somebody's backyard, and so they may keep the installation low. You got to think about the service down the road. So I would always encourage you, put it in a position where you're going to be able to do work on it. Tennessee is a state where this picture was taken, where they actually require disconnect in addition to the control panel. But again, mount the panel high enough to where when you got to go do service on it or when you got to do possibly rewire floats or something like that, it's easy to access. As I mentioned already, anytime you penetrate the enclosure, you're eating into the NEMA rating on the control panel enclosure. So we want to make sure that you use fittings, penetrations that are sized properly for the holes that you drilled through the panel with. We want to avoid holes in the top of the panel and the sides of the panel. Gravity is going to work against us if we've got penetrations in the top of the panel or the sides of the panel as precipitation runs down on the control panel. Those top holes and side holes, just a little greater chance that you're going to get leaking and penetration of liquid into the panel. And there's an example of a hole that was put into the top of the panel, and then they run a conduit hub down into it with no gasket, no sealing material, and also it's kind of hard to tell from this picture, but the hole that they drilled is a little bit bigger than what the conduit fitting required. So guess what happens? You're going to get a leak there, I guarantee it. Here's another picture of the inside of a panel. Same deal. There was no gasket on the exterior side of the control panel penetration or the fitting. You can see we got, water leaking down into the control panel, which is the last place in the world we want moisture or water. Guess what? The inside of the panel is not going to look very good. A couple of months down the road if we've got moisture building up inside the enclosure. Proper liquid type fittings on these penetrations. We already talked a little bit about it, but spend a little bit more money, a little more ahead of time. Have the right fittings to do the job right, and the equipment's going to last a whole lot longer if you take a few steps originally. And then, as I mentioned, we already talked about some of these penetration fittings that are available. Whether you get it from us or some other manufacturer, I don't really care. Just use the right ones for the application. Here's an example where they had a conduit hub going into the panel. They went into the bottom of the panel. They did everything right, except they didn't glue the conduit up into the conduit hub. So after a couple of months, you got some settling out there. The conduit actually dropped down, and reality is it's not going to have a real negative effect on the panel for this particular picture, but it is a gateway to get liquid rainwater down into our tank. So, typically, it's the last thing we want to do is introduce surface water, rainwater into our septic tank. Here's an example of an installation with one of our products. They did everything right. This JB plugger is designed to go into the ground beside your riser, and you're going to use a conduit seal there. You're going to use that seals off gas. What they didn't do is they didn't secure the lid down tight and screw it in so the NEMA rated gasket can seal everything off. I don't know if you can tell, but that's mud in there. So when the pump wasn't working properly, service guy got out to the job, opened the panel door the rest of the way, it was full of mud. So no real shock that they had problems and the system didn't work properly. All right, mount float switches so they actuate freely. You also want to mount float switches so they can easily be removed. So in talking about a float tree or a float bracket where we can access the floats from the top of the tank, certainly makes service a whole lot easier 4, 5, 6 years down the road if we can access them from the top of the riser. And here's a couple of options. Here they're showing the discharge pipe and the pump being used as your float tree. That works fine. The only negative to doing it this way is to do any service on the float switches, you also have to pull the pump out. Same thing on this other picture. Last thing I want to end up with, unless there's any other questions on installation, you know, it's a 1-hour meeting, so we can't get real in depth, but any other questions regarding the installation? Yes, sir.
On those floats, basically they're all the same, right? The same float as how you wire them in the
Not so far as the stop, start, alarm, and lag float. Yes, they're all going to be either normally open or normally switched, normally open or normally closed. They're all going to be the same so far as the switches you use. One other thing to mention about that is we never want to use a control switch to operate a pump directly, and we never want to use a pump switch to work with a control panel. All right? That's pretty important. With a pump switch, especially mechanical, it's going to rely on a cleansing arc when we bring the contacts together or pull them apart to keep everything operating properly and keep the contacts clean. If you took that same pump switch and used it in a control panel application, you're not going to get the cleansing arc. So what typically is going to happen, everything's going to work fine for a little bit of time. And then those contacts will start to carbon up, get a little bit sticky, and you're just not going to get a whole lot of service life out of the switch. So again, keep in mind, pump switches are used for directly operating, taking full load for the pump. Control switches are used with control panels and alarms. All right, last thing I want to talk about is when choosing a manufacturer, whether it's a float switch or a control panel, a couple things that I think should be a no-brainer, but we'll point them out anyways. Some type of warranty that gives you and your home and your customers peace of mind that they're going to have good service life out of the product. Third-party validation, somebody besides me that says that the product I'm manufacturing is safe when used according to its intended use and also is going to hold up well over time. Something I would also ask you to look for documentation, installation instructions that make the install much easier to do accurately and properly. Look for wiring schematics to be packaged with the control panels that make it a whole lot easier to get things installed properly. Complete control packages. One of the things that we do that's a little bit different from some of our competitors, we manufacture the float switches. We manufacture the control panels. In the control panels, if there's a circuit board in there, we manufacture it in-house. We don't farm it out. So I would recommend that you look for a manufacturer that has complete control packages that they make available to you, not farming out components from several different manufacturers. A little more quality control that way. And then obviously look for easy to install, reliable products that you get good years of life out of. And then professional design. The equipment that you guys install reflects directly on you to your customers. So I would just encourage you to look for the best bang for the buck that you can get. And again, just reflects well on you guys. All right, that's it. I appreciate everybody sitting through. If there are any questions, you can either holler them out now or come by our booth. We're going to be here for the next day like you guys, and feel free to come by and see us. Thank you very much, guys.